Okay, we're looking at solving linear equations. Before we start this, I want to give you some background. So basically, two linear equations will be in this form: y equals mx plus c, and there's three scenarios I want to go through with you. A unique solution is basically when the gradients of the two equations are different, 2 and minus 2. In this case, the lines must cross. There's one solution, or a unique solution. In this scenario, the gradients of the two equations are the same, 2 and 2, which means that the lines will be running with the same gradient, or in this case parallel. The y-intercepts are different, which means they will run parallel. That's another scenario. The last scenario, infinitely many solutions. Basically, the two lines will run on top of each other. They're the same line. They have the same gradient and the same y-intercept. These are the two equations here, just for an example. They don't look the same. However, if you multiply this equation by 4, you get this equation exactly. So they really are the same equation. Up here, another way of solving linear equations is using the matrix method, which you should be familiar with. To solve using the matrix method, we take the coefficients of y and x, put it into a matrix, find the inverse multiplied by the solutions. If you do that for this particular example, you will find that the calculator will say something like singular matrix, meaning there's no solution. This example is actually the last one, the last scenario, infinitely many solutions. Another thing to note here, and this is a quick way to determine whether there's a solution or not, is to look at the determinant of the matrix. The determinant of the matrix is A times D minus B times C. In this example, 1 times minus 8, take away 4 times minus 2, negative 8 plus 8, 0. So if we get 0 for the determinant, there is no solution. Okay, let's have a look at a question. This is exercise 2F, question 2. And it says here to explain why these two equations have no solution. So first of all, if we just look at the determinant is A times D, so it's 2 times 6, take away 3 times 4, 12 times 12 minus 12 is 0. The determinant is 0, therefore no solution. Or another method is, if we put it into y equals form, like these examples, we can then determine whether the gradient is the same. If the gradient's the same, there's no solution. So let's do that. We've got 2x plus 3y equals 6. I'm going to make y the subject. I'll move 2x to the other side of the equation, then I'm going to divide by 3. If I do that, y equals negative 2x, and I'm going to divide by 3 as well, all in one step, plus 6 divided by 3, which is 2. That's that equation transformed. The other equation, 4x plus 6y equals 10. Let's make y the subject. So let's move 4x to the other side of the equation. I get minus 4x. I'm also going to divide by 6 over 6. And then we've got 10 divided by 6 as well. If you have a look, minus 2 over 3 is the same as minus 2 over 3 if we simplify this fraction. They have the same gradients, so the gradients are the same. So basically we're saying, we're looking at this scenario, the gradients are the same. The y-intercepts are different, however. So in this case we've got no solution. This is the example or scenario that we've got. The lines are running parallel. That's why there are no solutions for that particular example. This question, or these types of questions, are very common on past exams. In fact, they come up as a multiple choice question on most exams. And if you guys have a look at them, go to the VCAR website and Google these exams, 2010, 9 and 8, as a starting point. Look at those questions on exam 2 and you'll see where these problems come up. Get your head around it, make sure you understand it, and remember that good students always do all their homework.